Hey all, welcome to my channel Hierarchy. If you are watching my video for the first time, make sure you subscribe my channel because in this channel I'm posting a full AI course. So if you didn't subscribe it, you might be missing the notification. So you'll not be on the learning journey. So yeah, today's video we are going to see about types of regression. This is one of the most important topic when it comes to machine learning because regression is the foundation of all machine learning algorithms. Yes, let's get started. The first type of regression that we are going to see is linear regression. This is a kind of algorithm. If your goal is to predict a mark of a student, how you will be predicting it? Based on how many hours they studied, specifically the hours of focused study. So just by using the focused hour of study, you can clearly understand how much mark the student could score. So in this scenario, using a one column, I am going to predict another column. And if the value of this column decreases, if student is studying just for 30 minutes, they might score less. If they are studying for 1 hour with more focus, they might score more. So if value decreases on one column and the value decreases on target column 2. If it increases on one column, it increases on the target column too. So in this kind of scenarios, I'll be using linear regression. The second type of algorithm that we are going to see is multiple linear regression. It is almost similar to linear regression. But here, we are not going to predict one column with one column. Instead, we do have more or equal to two columns. So if I have two or more columns to predict my target column, and the relationship is linear. If the value increases in these columns, the value also get increased in my target column. In such scenario, I'll be using multiple linear regression. For example, if my goal is to predict healthcare cost of a particular person based on their age, their lifestyle, and also their disease, what kind of disease they do have. So based on all these columns, if I'm trying to predict their healthcare cost. So in this scenario, all these columns has direct relationship to healthcare cost, right? So if a person's age is more than 40, there are high chances the healthcare cost might be high. If the person is having any diseases, it says that my healthcare cost is going to be high. If their lifestyle is not healthy, instead they are having unhealthy habits like eating junk foods, not doing any exercises, it definitely says their healthcare cost is going to be high. So it says that it has a linear relationship. If I'm using so many columns, two or more columns to predict my target column, and it has a linear relationship. In such kind of scenario, I'll be using multiple linear regression. The third type of regression that we are going to see is polynomial regression. In this particular regression type, you are not going to have any linear relationship. There are chances the one column might have values that are getting decreased, but in my target column, there are chances the value might get increased. There are chances my feature value might get increased, but in my target column, the values might get decreased. So in such scenario, I'll be using polynomial regression. So the relationship is quite harder to understand. The line, the graph that we are going to plot by using this algorithm is not going to be a straight line. It is going to be a curve-like line. So in that scenario, whenever my data is not having any linear relationship, for example, stock market analysis, you know about that, right? We can't exactly predict what is going to happen this month, next month, and upcoming months. It is unpredictable, right? So in such scenarios, specifically in business growth, if I am predicting my business growth, it is impossible to predict accurately. So the data is quite complicated to understand. The relationships are not linear. So it has non-linear relationships. In such scenarios, I'll be using polynomial regression. The fourth type of regression algorithm we are going to see is ridge regression. And the fifth type is lasso regression. These two algorithms have a relationship. Both are regularization techniques. Whenever my model is having an issue of overfitting, I'll be using a step-by-step process to reduce that overfitting problem. So my data is not going to be learned by my model in a way. It is not going to memorize my data. Instead, it should be learning it. In case if it memorizes my data, it is called as overfitting. So specifically to avoid that overfitting, it follows a certain step-by-step process that is called as regularization. So this ridge regression is also called as L2 regularization, and lasso regression is also called as L1 regularization. In ridge regression, it is specifically used for reducing the overfitting. So if I have a goal of working with finance-based data sets, there are high chances it might get overfitting. Mostly it will be memorizing my data instead of learning, because it is not going to be smooth curve, or it is not going to be a straight line. So in such scenarios, I'll be using lasso regression to avoid that problem. And when it comes to lasso regression, so this kind of regression is specifically used for selecting the important features. If I have 10 columns in my data set, one column is going to be as my target column, and the remaining 9 columns are features. In my case study, there are chances I might not need all the 9 columns to predict the target column. So if I just need 4 columns to predict my target column, what are those 4 columns? What are those 4 important columns to predict my target column? So the process of selecting the important features or important columns to predict my target column is called as specifically, this is the step by step I'm going to use in lasso regression. So this is how it generally works. So in case if I am selecting medical features that is directly assigned with a disease prediction, for example, if I'm going to predict if this particular person is going to get a heart disease in future or not, I might have so many columns like age, weight, BMI, their ID number, and so many columns. Some columns may not be necessary to find their prediction of heart disease in the future. So removing those unwanted columns and keeping the necessary columns. So predicting that features and selecting the important features, this is what we are going to do with this lasso regression. For specifically for selecting the features, we'll be using this lasso regression. And the sixth regression algorithm that we are going to see is elastic net regression. In case if I am having complicated machine learning pipelines, which is quite harder to understand, if I see the data, I can't understand anything. If I plot a graph, I can't understand anything. It is so messy. In that scenario, my go-to algorithm is elastic net regression. So in this particular regression algorithm, the data set that I'm going to work with is going to have overfitting. The features are hard to select. It is going to have messy data. So I have the data with all the complications. So for that kind of problem, for that kind of data set, I'll be using elastic net regression. So it is a combination of lasso regression and ridge regression. The seventh type of algorithm that we are going to see is decision tree regression. Whenever I want to increase the accuracy of my model, what I should do? I'll be adding conditions to each and every steps. If this condition is satisfied, take this decision. If it is not satisfied, use the another condition and check if it is true or not. Then take this decision. So if I'm giving the process of use this condition, check this condition, and if this condition matches, take the decision. Condition, decision. So if I'm using this process, then it comes under decision tree regression. So for this kind of regression, what kind of problems I might have? If I am running a business, I do want to group my customers based on their behavior. So it is called as customer segmentation, based on what they are buying or based on how frequently they are purchasing, how frequently they are visiting my outlet shop, or how frequently they are visiting my website, how much they are buying each and every time. So based on this, if I need to do the segmentation, so that is called as customer segmentation. So for that kind of problems, I'll be using decision tree regression. So to analyze their behavior and do that grouping process, I'll be using this decision tree regression. So in such scenario, there are chances my model may not perform well if I just add very few conditions or one or two conditions. If I want to add multiple conditions, I want to combine multiple trees to increase the accuracy of my model, to increase the performance of my model, and to reduce the overfitting. My data should not be memorized. Instead, my model should learn my data. So for that purpose, I'll be using random forest regression. In decision tree, I have some problems. To overcome that problem, I have another algorithm called random forest regression. So this particular random forest regression is capable of handling multiple data sets. So if it is having a big data, it is capable of handling it. So in this particular regression, we'll be combining many decision trees and we'll be forming a big random forest regression tree. So it will be used for taking a decision. So the performance will get increased and the errors will get reduced, and also the overfitting also will get reduced. The ninth type of regression that we are going to see is gradient boost regression. Actually, it is one of the industry's favorite. See, it is actually one of the industry's favorite because it is specifically used for improving the errors. It means it reduces the errors. So it increases the performance. If I have a complicated data, this is super powerful in understanding that. Do you know what? If you are a beginner in ML or data science and AI, you might definitely participate in Kaggle competitions, right? So for that competitions, to win in that kind of competitions, this is one of the go-to algorithm because it understands the complicated problems inside and the patterns inside my data. So gradient boosting is such a powerful and industry favorite algorithm, specifically for reducing the errors. So it can clearly understand my data and it will not be memorizing my data. The 10th type of algorithm we are going to see is support vector regression. It is actually one of the simple algorithm, but still it is super powerful in this year. Why? If I need to work with small data set, not every time I need huge data set to process, right? And specifically, if I want to work on time series based problem, this algorithm actually process and it will follow a margin based approach. So it will be grouping my data into two different segments. So features and my targets. So based on how it understands. So in such scenario, when I want to deal with small data set and if I have time series analysis to understand and work on, if my data is changing based on the time scenarios for this month, for next month, for maybe the gold price predictions. So in that kind of scenarios, I'll be using this support vector regression. The final algorithm that we are going to see is actually the queen and king of all regression algorithms. It's absolutely the neural network regression. In this year, in current scenario, we are often dealing with live data, right? That we collect from weather, that we collect from news channels, that we collect from education, the researches. So for handling live data, specifically the sensor data that we get for IoT based projects, we need a super powerful algorithm, right? That is definitely the neural network regression. If my goal is handling live data, then the go-to algorithm is neural network regression, specifically even in robotics. It clearly understands and processes the data. So I believe you clearly understood all these regression based algorithms. If you want notes on all these topics, clearly just go and check out the description. I've clearly gave you the topics, not just these abbreviations, the topics and the explanation. So you can take notes on them. I believe this video helped you a lot in understanding the types of regression specifically for this trending year. So yeah, bye for now. We'll meet you in next amazing video. If you have any doubts, without hesitation, drop them in comments. Bye.